an activity where you did GRC shields up. Does everybody remember seeing a screen somewhat like this? Maybe not with all the blues, but
Yes. Yep.
okay. Now, if you've received a result from GRC shields up, it looks like a variety of ports have been unshielded by your firewall. This is a glaring example of how some network exposures are prevalent on your local area network. And essentially, this is a sure sign that additional investigation is warranted. Now, this may mean that you have exposures on your own client with open port and firewall rules, or there could be other activity that's present on your local area network, and depending on which firewall is active, these this output or results could be part of other connected clients if the firewall that's in place between you and GRC shields up is your Wi-Fi router. So this may be, put another way, this could be a result of what's happening on your local firewall with your local client, or it could be a summary of the exposures on your local area network with your Wi-Fi firewall. And so it's important to understand that distinction. You have more than one firewall. So you have a firewall on your local Windows and Mac system, but you also have a Wi-Fi router that has a firewall. And so this is called defense in depth. We'll talk about that more in a minute. In any case, if this is the output for a single client on your network, this could indicate the presence of a remote access Trojan, meaning your system's been owned, it's infected, and whoever has control of your system has established open ports that they can use to reestablish connections or reconnect to make sure their backdoor access remains intact. So anytime you see this again, it's just something you'd want to pay attention to. Now, essentially, the linchpin is investing in a managed switch. Did we not talk about managed versus unmanaged switches in our last session? If you go to a vendor to buy a switch for your environment, make sure you get a managed switch that has an IP helper or DHCP helper capacity. This is going to pin whichever host connects to your network down to get the information it's supposed to have from your infrastructure and not from a hacker that's lurking on your network. It's also going to allow you to work a lot more efficiently by segmenting networks, and we'll talk about that more in a minute. So that's one of the important linchpins that, and it's not, again, this is a 48 port gigabit Ethernet switch that's only $320, so it's less than $10 per switch. So in any case, once you pin devices down to the proper DHCP server so that they are required to get their address from your DHCP, you can define the network criteria to include the DNS, right? So you can lock down what your clients are getting. They can't get a fake DNS server. They can't be redirected to an imposter DNS server or a malicious DNS server. So this is part of what we call defense in depth. And speaking of that, what I'd like to do is explain some basics here. So I'd like to kind of walk through this diagram section by section so that you get a chance to understand what it's about. Can everybody see the screen?
Yeah.
Yeah.
Okay. So if you think of a a network, we have two characteristics of most networks: the local and the public, right? So, and this is true for most home environments too. So home networks work like this, business networks work like this. And essentially what you're looking at are typical symbols that are used to draw these pieces of equipment. But at a minimum, you want to have layers of network security components starting from the outside and working all the way in, right? And that's the way most people think. They think mostly in terms of the exposed internet, and it's actually a better practice to think about the inside first. So what you see here is the private internal network. Now you know that private internal networks are certain address ranges, okay? 10.0, 10 dot something, 172.16 dot something, or 192.168 dot something. Those are private non-routable address ranges. And it's consistent that most network security experts will agree that for the average hacker, the use of a private non-routable internal address range makes it more difficult for the average hacker. Now, if you're talking about nation states, that changes the picture. But what's also important is that for different populations of devices, you should establish different networks. For example, if you have a mid-sized organization, you could have a 10.10.10 network for servers, a 10.10.20 network for staff. If we were using the university as an example, a 10.10.30 for faculty, a 10.10.40 for non-resident students, 50 for dorm students, 60 for guests, and so on. You want to have separate, smaller networks. And so, and we'll get back to this screen in a minute. I want to focus on this particular diagram. So even though people think about the big bad internet and they think, okay, I have a router, it's got a firewall, I'm good. It's actually a mistake to think in terms of network security by starting from the outside and just putting a door out there and then saying, okay, we're done. It's better to look on the inside. And I mentioned managed switches. So what you want to do is you want to have a managed switch that allows you to easily create separate networks and then create routes between those networks as needed, right? So you know that clients are going to be using server information, and you can control how and which clients access each other, provided they're in separate networks. But if they're not, if they're all in one big massive network, and there is no definition between those client populations, then you cannot exercise nearly as much control over which hosts can access which components. And a basic setup like this is incredibly troublesome. It's easy to set up, and most average hackers don't expect this. They expect everybody to have a huge open network where everything is just lumped together and they can kind of have free reign here. Now, the other thing that I wanted to call out that's not so intuitive here is you see this reference to DNS. And in our last module, we mentioned this thing called split DNS, where we have internal DNS servers that help our clients find things out on the open internet to resolve common names for addresses. But then we also have another DNS out on the perimeter, out toward that's exposed to the internet. So we split the roles and the placement of DNS servers so that there's actually a pair of them. There's a second DNS server here that does the actual name resolution, and it relays that back to the inside. If this outer DNS server gets hacked, the only thing they're going to get for records are what someone inside the organization was browsing on the web, but they don't even know who. And then the other DNS server is what you use to advertise your zones. So if your organization has web servers and email servers and applications, right, then that DNS server is, that role has been removed from the inside. If that server is hacked, the only thing that a hacker gets out of that server is the information that everybody else has in the first place out on the internet. If you only have one DNS server and it shows where everybody is browsing, then you get intelligence on what the interests are for your users. If you only have one DNS server and it also includes the zone records, then you learn all of the sensitive network addresses for all of the named resources in that network environment. Put another way, if you put all your DNS eggs in one basket, you're a sitting duck. In combination with managed switches, a robust DHCP service that has IP helper, this split DNS is really important, because what you're doing is providing the DNS functions or resources, but you're splitting that up so that if one piece is lost, the rest of your organization inside is not exposed, where everybody can tell where your most important machines are. And what I'm going to do is stop at this stage and just ask, based on the information that I've presented, and by the way, this is the symbol for a managed switch, in case that's what Cisco uses, one of the symbols. That's a router symbol, that's a firewall symbol, and it's an oversimplification of a hand drawing. Does anyone have any questions based on the review the material presented so far? Anyone? Okay. Can someone unmute your mic and let me know that we're still together, because we had some heavy rain. I don't know if the network was disrupted. Are we still together?
Yep.
Yeah, I'm still there.
Okay. So this is just a rough hand drawing of a schematic that shows these different subnets, right? And the different infrastructure. WSUS is a Windows software update server, right? So you can actually push rapid updates inside. If you get a single copy of an update, this is stuff that we cover in other classes too. But being able to quickly and easily update Windows or your clients, whether they're host clients or their servers, that's really important. So whether you're dealing with clients or you're dealing with servers, bigger machines with lots of resources that everyone uses, you're going to want to make sure that you have this. Now, part of the managed switch scenario is having this layer 3 or core switch. That's the part, if you see a reference to layer 3 or core switch, that's a switch that includes some routing that allows quick setup of these segmented networks with essential routes in between, where you control the traffic between those host populations. Now, that's the end or edge of what we'd call the private internal non-routable network. And then out here, you have the open internet. And in between, you have this special zone called a demilitarized zone, or DMZ. Have you ever heard the term DMZ before? In military terms, a DMZ is a hot zone. It's closer to the threat. So a perimeter network is a network that's removed from but connected to the internal network. And it's explicitly and intentionally designed with additional security measures to harden anything that's out here that we would call public facing. If this is the public network, anything that's closest to that public network is said to be public facing. Does that make sense? So if you have a web server, an email server, right? You have your own DNS servers that advertise what you have and offer to the rest of the world, websites and email. See, those are public facing hosts. And because they're in this hot zone or perimeter network, they're considered to be hardened. They have extra security measures in place. They have a much tighter firewall configuration. They have additional access control lists, which is what ACL stands for, access control list. So a router with an access control list, if it sees network traffic coming to or from the public network and it's not in the access list, it just drops it, right? So this is kind of like a bulldozer in front of the firewall. And if this is configured properly, the firewall has lots of breathing room to do its job. If this is never configured properly, the firewall is overworked. So that's one thing to understand. You'll notice that this is where we also have VPN and the word proxy. This is a really important concept. If we browse, we have people in here that browse the internet. Those requests to browse should flow outbound through a proxy server. And it's this proxy server that actually interacts with bad guys out on the net, okay? VPN, of course, is how remote users connect to their internal network environment and resources. So people use a virtual private network connection to get to the important resources for their office environment securely. It's where the VPN, the proxy, the web server, the email server, the service router, and the advanced firewall or stateful firewall, right? This firewall, all these components are out here in the perimeter. There's a separate network called the perimeter network, and there could be more than one of them. So we could have a separate network for VPN connections, a separate network for proxy and firewall, a separate network for our hosts that face the public, or web server and email and DNS. So we could have separate subnets out here in the perimeter, but collectively, and spam filters. When you get email spam, a lot of that is filtered out when it hits the perimeter network, and there's a special piece of equipment that's really good at eating spam. Barracuda is one brand name that's actually pretty prominent and pretty popular, but there are many different kinds of spam filters. And so these extra layers of defense, when people are sending email in and it's malicious email, this spam filter can crunch and munch it before it ever gets inside, right? So these are the essentials that you need to have in the perimeter. A firewall that also branches out to different networks. The one that's public facing would be called a DMZ, right? A demilitarized zone. These are exposed. By the way, when there are extra security measures, we refer to those hosts with hardened security as a bastion host. Bastion meaning like castle. It's not the other word that sounds like it, in case you were wondering. Out here in the open, this is the wild, wild west. This is the open internet, and everything is terribly exposed. Public network addresses flow to and from the network wires and routes and between routers out here. And this is like, you don't ever want to have network stuff out here, ever, 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 ever. So this concludes a basic walkthrough. I did include a different diagram that goes into a little more detail with some extra notes like virtual LANs and other stuff. I'm just going to throw this in here for you to have a quick look. I was explaining some things in greater detail, but this is, you see the reference to virtual LANs. Those are virtual internal LANs, right? And this is a bad guy in the middle of this trying to figure out, okay, why can't I see any servers? Because I just hacked a PC. And that's because they're not in the same network. I don't know if that makes sense or not. An intrusion detection system is watching for suspicious activity. It's typical that a lot of malicious actors, when they get inside, they start doing certain things. And an IDS or intrusion detection system is actually listed here, right here. You can have an intrusion detection system inside. You can actually have an intrusion detection system out here. You want multiple layers of defense, and you want to structure your environment so that it's not simple to get around with if you're an uninvited guest. That's the main goal. Now, the perimeter components at a minimum include a stateful firewall, one or more screen subnets, and routers with ACLs. The internal components at a minimum include a layer 3 core switch for virtual LANs and managed networks, private subnets for different populations of users, and DNS in both areas, right? With intrusion detection inside. Remember that you don't want to start out on the perimeter. You want to start with the inside and build your defenses out. And if you don't have a private, non-routable internal network to begin with, shame on you. And I'm talking to everybody and anybody out there in the Caribbean who makes a nasty habit of just getting IP addresses from their service provider, and they just issue those IP addresses directly to hosts. They are sitting ducks, and it's not funny, and it's horrible that somebody would be using a public IP address. Just saying. Why are network security problems a challenge in the first place? Well, that's because the tech folks want things to work, and the security people want them to be locked down, and there's kind of a tug of war that goes on. I didn't know if you were aware of that, but there's other quick and important information, right? And there's mention of the pie hole, right? So more and more, there's many redirection when you click links or you respond on screen. The bad people are starting to embed these redirections in other links. And this is actually a really cool thing to do. So I just thought I'd mention that.